Hi, yeah, so as Matt just said, I'm David Yatsin. I'm a senior engineer at Sangoma Technologies, and I'm here to speak about LibWAT, which is a library, a GSM library that we want to integrate with Asterisk. So first, I wasn't sure what my audience was coming here, so there's two things kind of I wanted to go over before I move forward to explain what LibWAT is. First is why people use GSM with Asterisk. The other one is kind of like go very quickly through the basics of how to interface with GSM modules. Your PBX is fixed, right? It stays in your office, and some people who might think, why would you want to have mobile technology integrated with your PBX? Sometimes it seems like it doesn't make sense, right? So why you would use GSM? It's mostly for the Europe and Latin America market, but from what we've seen, we have a lot of providers that have those packages where cell-to-cell or cell-to-cell phones are free, or they cost a lot less compared to LAN-to-cell phone. So that's the primary reason we've had people integrate GSM with Asterisk. It's for cost reduction, right? So if you're that company that has a lot of agents in the field, either sales or technicians, and you know that you have people in your office that will be calling them several times during the day, you can add that GSM card on top of your existing PRI or analog line, and you modify your dial plan so when someone from the office calls out, instead of using your PRI or analog lines, it would use your GSM card, so your call is either free or will cost you a lot less than if that call would go through a lead line. Another feature you could use GSM with Asterisk is as a simple SMS server. Same thing if you have your agents in the field, you want to broadcast one SMS to everyone, but can easily be done with a GSM card and Asterisk inside. A third way you could use it is a kind of failover backup line. There's a chance that if your PSTN or your analog line goes down, right, your GSM network will probably still be up. So if you have your GSM card there, your office can still make calls in and out of the office. It's probably not ideal, but that's still better than not being able to make phone calls at all in your office. So the next thing was, kind of going quickly through kind of GSM module interface basics. So most of the GSM modules out there, they use the Haze AT command set. It's a plain text, simple command line based interface. It was originally used by modems, but then when people started making modules for cell phones, they just reused that same interface. Most of those commands are specified in a spec called 3GPP TS27.2007. So, let's go quickly kind of how a voice call works. So if you want to make an outgoing call, what you do is you transmit ATD, and then the number you want to dial, and then when the other side answers, you get an OK back. So you know it's answered, you can start bridging your media. On an incoming call, you would get a ring event. If you have a caller ID enabled, you would get that plus CLIP command followed by the caller ID. And if you choose to answer the call, you transmit an ATA. So as you can see, it's a fairly simple command. It's command interface. It's not like a PRI where you would need Wireshark or an interpreter trace to figure out what's going on. Just from just printing what's being transmitted on that AT interface, you can see what Asterisk is trying to do or what the GSM module is trying to do. So now I can go back to LibWAT. So LibWAT is LibWAT stands for Wireless AT Commands Library. So it's a protocol stack, and its role would be to encode and decode AT commands and turn them into events so that your user application, which would be Asterisk, can interpret them on, in an abstracted way, kind of like the call is starting or call hang up, and then you can make your calls. For those, I'm sure, I think you guys are all familiar with libPRI, libSS7, or OpenR2. So LibWAT would have the exact same role. It handles signaling and call control. So it doesn't handle media. It handles, when the call is started, when to bridge media or when to hang up. So for those who know about GSM, you probably know that there's also a good amount of GSM implementations out there already. There's multiple vendors. There's probably, I don't know, 3 or 4 I can list. But there's kind of some drawbacks with and some problems with the current way things are, right? So each one of these vendors, they use their own software package, right? So these packages are not included in Asterisk, and right away that kind of causes problem. If you guys have installed Asterisk with libPRI, you know it's very straightforward, right? You download 3 packages like Daddy, libPRI, Asterisk. You have to configure, make install, you're done. If you want to install a GSM card right now, you have to look for that other package from your vendor. Some of them require you to patch Asterisk, and I don't know if you guys have dealt with patches before. It sometimes gets really painful, right? Because the patches are always like a couple steps behind. So sometimes new Asterisk comes out with either a new feature or a bug fix that you really want, but for some reason that patch is not ready yet. You don't have a patch for that version of Asterisk yet. So you have to wait a couple of weeks to get the new patch or a couple of months. So it's not the greatest. There are some other implementations out there that they even bundle Asterisk. So you download their package and then they tell you, okay, these are the versions of Asterisk you could download, and then it would work. Now, this is great in some sense that, okay, that version of Asterisk has been tested with their package, so you know that the GSM section will work very well, right? But then what happens with, let's say, the SIP section or the EX component of that version of Asterisk? What if you wanted a SIP component from a newer version of Asterisk, right? So there's problems there. And the third issue is each one of these packages, because no vendor will try to kind of build a package that will support their competitor. Each one of these packages only support a specific vendor, right? So you want to use a card from Sangoma, you use a package from Sangoma. You want to use from another vendor, you have to use another package, right? And each one has slightly different installation procedure, different dial plan commands, different scripts. So, the other problem that causes is if you want to, at some point, you're like, okay, I want to try that other card. Now, you have to slightly modify your dial plan. It's not a big deal, but if you've tested your dial plan, you've already worked with that for months, sometimes you just don't want to change it. Or your scripts, you have to slightly modify your scripts to make it work, or your monitoring, however you monitor if your link is still up and down. There's some work to do, so it's not as straightforward compared to, let's say, if you had libPRI, as long as you have a Daddy compatible card, you don't really care what the card is at your later one. It's always libPRI and Asterisk. It always looks the same, whatever card is running below. So, after going through all those kind of problems with the current situation, I kind of wanted to go over, so why we should have a generic AT library that the same way libPRI or libSS7 is, where they work with any hardware, any Daddy compatible hardware. I think we should have a GSM library that works with any hardware out there, right? That would make everybody's life easier. And a couple of reasons I wanted to go over is, well, the more users you have, if you have more users, you'll have more developers willing to add new features to that. And you'll also have a more stable product, right? If you have thousands of people using it in the field, then you'd be less scared of putting this new GSM installation in production. So if you have a generic library, just kind of same way libPRI, it's a lot easier to install. All the versions of Asterisk will be supported, because as soon as Asterisk comes out, it's supported right away out of the box. You don't need to patch or make sure you test with that specific version. Gives you the ability to switch hardware vendor without having to modify your dial plan or scripts. I think I went over installation would be simpler. I think we all agree that libPRI and libSS7 have been successful so far. It works well. Everybody is happy to use it. So, why not have the same thing for a GSM library? So, when we started, designing LibWAT, those were kind of the features we wanted, right? So first thing, it had to be open source. We want more people to contribute to it. We want everybody to be able to use it. So it has to be open source, the same way Asterisk, we're an open source community. We want to be able to easily add new AT commands or new features without kind of having to worry too much about like going back to make sure like the parser will work well or stability. We want to have support for kind of vendor-specific AT commands. So in one of the first slides, I went over like and I explained how like a lot of these commands are specified in the 3GPP TS 27.007 spec, right? But that spec is kind of very limited in general. It defines like the very core commands, kind of like how to make a voice call, how to answer the call, how to hang up. But a lot of GSM vendors out there, they've added a couple of features kind of to differentiate their product that may help, or not within that spec. One example is, let's say, to disable the hardware co-canceller. Or let's say if you had a feature to enhance the voice quality or something, those kind of commands are not specified in the 3GPP specs, right? So what the vendors do is, since there's no existing command provider, they come up with their own command, right? Now, the problem is, well, let's say you use a module from Telit, and that command works with Telit. That same command will not work with, let's say, a module from Motorola. So, we wanted a way to be able to support all these manufacturers in a kind of an easy way. The other requirement we wanted was an AMI interface. Sending SMS via like, kind of asterisk CLI is helpful when you want to debug, but if you're trying to, kind of send a lot of SMS, or you want to know when your SMS was delivered, you want more control, you need to go through the AMI interface. It's probably the easiest way to go right around. And also, if you want to send, let's say, SMS in other languages, like Spanish, for example, you need to go through AMI interface because there's some characters you won't be able to enter from the CLI. We wanted it to be kind of easy to maintain and debug. We wanted it to be scalable. So we wanted it to kind of be very integrated with Asterisk, kind of have the same way Asterisk works right now. There's a lot of verbals that, you can adjust your verbals level depending on what you're trying to debug, or you can even enable debugging if you're trying to kind of, as a developer, try to figure out what's wrong. So the way kind of LibWAT sits within Asterisk is, so if you guys are familiar, Asterisk have multiple channel drivers to handle the different technologies. So there's CHAN SIP to handle SIP, CHAN EX to handle EX, and then there's CHAN Daddy to handle Daddy cards, Daddy interface cards. Inside CHAN Daddy now, there's usually, the same way there's libPRI and libSS7, LibWAT kind of fits the same way. So what happens is CHAN Daddy will have a handler over your Daddy card below, your Daddy device. And, but then when it reads data of your Daddy device, it sends it to the library for decoding. The library then returns like events to say whether that's a new call or a call was hanged up, that kind of events. So, LibWAT kind of fits very well in that environment, the same way libPRI or libSS7 works. So this is more kind of for developers. I just wanted to demonstrate, how easy it is to add a new command to LibWAT. So we spent some time kind of working on the core so that every time you want to add a new command, it's fairly easy and straightforward. So this is like the function to implement, to add a new command. So the function name is wat command enqueue. The first parameter is your span structure, which, so you have one span for every GSM module, the actual command. The third parameter is a callback. So this is a function that will get callback when you get a response for that command. Callback object is basically when that callback function gets called back, that object will be a parameter. So if, let's say, this command was related to a call, then your object would be what you would use to kind of trace back and get kind of a pointer to your callback, to your kind of voice call when the callback gets called. Callback functions get called. And when the last parameter is the timeout, you just kind of, so if you send that command and within that timeout you don't get a response from your module, then you can assume there's a problem, you can print an alarm, there's something wrong. So that's what the timeout is here for. So one example is the ATZ command at the bottom. So the ATZ is probably one of the simplest commands. It's just a soft reset, just resets the GSM module. So if you want to send an ATZ command, you just call white command and Q, ATZ, the kind of a callback function. In that case, there's no call, so we don't need to attach an object. And the timeout here is 60,000 milliseconds, which is 60 seconds. And what happens is, so if that will send an ATZ to the module, when the module responds, that function, the what response ATZ function will get called back, and then you can proceed forward. You can do whatever you want, so you know you got a response. If it's an error, you can print an error. If you want to proceed forward with the initialization, you proceed forward. The other important thing we had when we were designing LibWAT, as I mentioned, was to be able to support vendor-specific, like hardware vendor-specific commands. So the way we arranged this was every vendor, hardware vendor, would have their own kind of module type. If you guys are familiar with PRIs, kind of we wanted to make it the same way as you can have a switch tab in PRI for URI ISDN or national ISDN or things like that. So for LibWAT, you have a module type which would specify which hardware you're using. So for Sangoma, since we're using the Telit module, so our file is called telit.c. And inside, for each hardware module, they register an interface within the LibWAT core where you have a start function, kind of a shutdown function, an initialization function. For example, this is the start function. So this shows kind of a Telit module commands, like commands specific to Telit that are called when the chip is initialized. I'm not going to go too much detail in those. Like the first one, SC lint equals to 2, just kind of modifies the way Telit module behaves. One thing that kind of may be more interesting is at the end, how like, for example, the command to enable the echo canceller is the SHFC equals to 1, for example, on the Telit module. But if you can see, for those who are familiar with the AT command set, all the commands out here are not generic commands, right? They are not specified in the 3GPP. Those will only work with Telit module, maybe only certain like model of a module. So as you can see, this is how we abstracted the different vendors from from the core. And if someone, let's say, had a Motorola chip, then they would have a Motorola.c where we'd have Motorola specific function inside that file. The other feature that we worked on was the AMI interface. We got a lot of requests for people that wanted to use this card just to send SMS. And as I mentioned, we think AMI is probably the best way to send SMS or receive SMS with asterisk and GSM. So as you can see, it would be really simple to send an SMS. So the action is, every AMI command, I believe, needs that action. So for us, it's what send SMS. The span specifies which span you want to send the SMS on. The to number is your destination number. The content, as you can see, the character set right now is ASCII, but you can also switch it to something like UTF-8 if you want to send Spanish characters. There's also the class. And the content is pretty much what you want to send in that SMS. So right now, I'm sending hello world. And once you're done building your command string, you just send the command. I think this was written in PHP. And as you can see, it's pretty straightforward. Kind of to show how powerful, about the AMI architecture can be. I wanted to go over an example of what one of our partner companies kind of implemented. So one of our partners, a company named Incuvox in Mexico, we had a contract for an electoral campaign where we had to send a lot of SMS. So they were processing they had to receive them as well. So they were processing about 100,000 SMS per hour, which is a fairly big number. They did that by splitting it over 12 Sangoma W400s. So in total, that's 48 GSM channels. So the way they did it is, to the left, they had a web server that displays, I think it was used for polling. I don't know exactly the details, what was inside the SMS message, but it was used to kind of as a survey to see what people wanted to vote for or something like that. So we had a web server that was displaying results. We had like a kind of a data server, also a master server where you have a database where it has all the phone numbers we want to send that survey to, and then it also like saves all the responses back to know kind of what who people would vote or something like that, right? And that master server would control several asterisk servers. It's not really a load problem when you're talking about GSM. Like, it's more of having enough PCI slots on a server. Like, right now we only fit 4 GSM modules in one PCI slot, so you're kind of limited to how many cards you can have. So, but for small deployment, you're fine. But for a scenario like that, they needed 12 boards, so we had to split it across multiple servers. So each of these servers, would send SMS over a wireless network, and then they would also process the responses back, send the response back to the main data server in the database, and then display the result back on the web server. So out of kind of the current features that we have with LibWAT right now, we support voice calls, kind of regular voice call, like make a call, what asterisk is used for. We also have the ability to kind of do progress detection. So there's a way to kind of poll the status of a call to see if the other side is already ringing, or the other side, if there's media ready, the same way there's progress and alert in PRI. Or there's a 183, for example, for SIP. So we can do that with LibWAT as well. And also SMS. So we can send SMS in either plain text, PDU mode, which is used to send those special characters or Spanish characters. And the other cool feature was that SMS server architecture that I just went through in the previous slide. So to download LibWAT, if you're a developer, I would recommend you download our kind of development version we have a GitHub repository. So this is the equivalent of downloading kind of a SVN trunk for asterisk, right? You get all the latest features. Unfortunately, it's not as tested, or it's, you would have to test it a lot before you put it in production. But if you're a developer, like, this is kind of the version you should use. Also, if you're a developer and you would like to contribute to the LibWAT project, contact us or contact me. Come see me. Like, I can give you like developer access. We can discuss about architecture or new features we can add and that kind of stuff. We're very open to that. If you're more of a user, we actually make occasionally releases, which are snapshots of the main repository, and you can download it from the second link. Right now, it's on our Sangoma FTP. And the instructions for the installations is on the Sangoma wiki for now. It's the third link below. We're hoping that if one day the Asterisk community adopts this will go actually on asterisk.org. So going forward, we have kind of two main features we want to add to LibWAT. The first one is SIM virtualization. So there's an architecture where some people wanted to have more SIM cards than GSM modules. And the way they do that is they can have there's special devices called SIM banks, where they can have a lot of SIM cards, maybe 48, 64, even 100 SIM cards, and but a lot less kind of GSM channels. And with software, you can kind of control which SIM card the GSM channel will control. So depending on, you can have rules to dynamically make it switch. So for one call, you would use one SIM card. And for the other call, where let's say you have maybe a better rate with that carrier for international call, you would switch to that other SIM card for making that call. Or if, let's say, that this SIM card, you're only allowed to make X amount of minutes per month, and you've already exceeded that, then you kind of stop using this SIM card for the rest of the month. So this can be dynamically changed. This is one feature we want to work. The other one is graphical SMS. So where, SMS can be sent in plain text, but there's also ways to make like some characters blink within the SMS or even send pictures inside the SMS. So that's something we want to spend some time on and support this feature. The main thing we're trying to get is the asterisk community support. So earlier this year when we implemented LibWAT, we were done and we had a patch for asterisk and we wanted to integrate that with asterisk. So we created a Jira issue, but the feature request was rejected. It's kind of understandable. I'm sure the asterisk community, the maintainers, they have like probably a dozen new feature requests or people trying to commit like every week. It's understandable. And so far, only Sangoma is using LibWAT, right? So if they accept LibWAT, it's they are favorizing Sangoma. So for now, they kind of rejected the proposal to commit that to the regular asterisk code. But I think, if we can get more users or more vendors or more developers like adopting this, I think we could eventually, within a couple of months, ping them and ask them to reconsider that request, right? I think if multiple users or multiple vendors use that, then it would be a more neutral library, and then they'll be more willing to push that with the asterisk community. I'm kind of done for now, so I have my email address where you guys can contact me, and if you guys have any questions, I'd be happy to answer them.
Any questions for David?
Just a question with regards to the SIM card banks. If you have, say, 48 cards and only 4 antennas, would you still be able to receive inbound SMSs for all 48 SIMs, or you have to pick 4 that you want to receive traffic from?
No, I believe you would only receive over 4 because the SIM card pretty much, I guess, for 44 remaining SIM cards would be kind of offline. So yes, you would. That would not work. It's more kind of for outbound control. Yeah.
Is there a list of available supported hardware?
Right now, currently, it's only Sangoma. So that's kind of why we're here. We're trying to get more vendors to use that. Well, we don't want this to be just a Sangoma library, right? We want this to be kind of a way LibPRI is. Everybody uses it. Everybody wants to use it. That's more why I'm here for. So right now, for example, it's Sangoma, but we would be happy to have more people joining in.
Do you support MMS or only SMS for only text, or can I send image also, for example?
For now, we only support SMS, but exactly, MMS was part of that graphical SMS support that we wanted to support in the future. Not really, I would say a couple months, yeah.
A good couple of things. One is, I suppose with the format of this, I draw the conclusion that you could do flash SMSs if you wanted it to pop up, depending on the format. If you use PDU format, you could do a flash SMS, which is the instant one that doesn't have to be opened.
Yes.
Additionally, this is not just exclusively SMS. This is voice, right, as well.
Exactly, yes.
So how much access do we get to the network signaling? And what I mean by that is, since GSM phones, the GSM architecture was designed to be an extension of the ISDN network, so they treat the phones like smart devices. So a lot of network signaling is shared with the phone or the device, such as, for example, if it was a forwarded call, a call comes, like you forward your home phone to your cell phone, the network will tell the phone that this is a forwarded call, and if the service provider actually allows you to do it, will actually say the forwarding number. They sometimes don't, but for confusion reasons. Is that kind of information signaling accessible, as well as signaling to set up multi-way calls, 6-way calls, things like that? I mean, it could get complicated.
Yeah, I may have to look a bit more on that. But this thing whatever kind of information you would have, let's say, on a cell phone right now, we kind of have the same information. We did not spend time too much on looking at whether we can determine whether a call was forwarded or not, but I would have to check.
Okay.
Yes.
And I mean, I suppose anything that the phone could have access to, including GPS information or what have you, if you had a portable asterisk implementation and it wanted to know where it was, it could potentially, knowing the right commands, could query the GPS coordinates.
Yes, so, but that you would need the right hardware. Like the GPS is a feature on the GSM module. Right now, most of the PCI-based ones, they don't really include the GPS just because right now it's designed to be inside the PBX, so you know where your PBX is. But that would be a feature that can be added on if your hardware supports that GPS chip. And for the flash SMS, let me see if I have that. It's usually that SMS Class thing. If you specify, I can't remember, like right now it's MES specific, which is mobile equipment specific, which is for the regular SMS. If there's different options, I can't remember them on top of my head, but if you change those, you can get the one that makes it pop directly on the user's cell phone, instead of being a message that's in the background. I think we're
Okay, question?
How many texts have you sent successfully, or as far as how many can you send in a minute or an hour? I mean, I know you had that study in Mexico where you were using a ton of them, like with one SIM card, one GSM. I mean, realistically, what is that supporting? What do you see that capable of?
when we were testing, it would take between 1 and 1.5 seconds to send an SMS on one module. So
So in theory, can you dump a lot in there and use it?
yes, exactly. So LibWAT has an internal SMS queue. It's open source right now. It's set. I think I set it to like something like 32, but we can always increase it, to anything.
You can only Q32. Is that what you're saying?
Yeah, so it will enqueue at 32, and then if you want to send one more, you'll get a kind of like a congested message, right? So usually what people would do with a PHP or AMI script is, then they would try to send on a different channel. Right.
You only have one.
Yes. Yes. And the other way is in that AMI, in my example, I was specifying a span, but you can also specify a group where it would go kind of round robin, split across all your modules within the same group.
By default, it's 32. By default, it's 32.
I think so, yes. If I remember correctly.
You gave an example with how to send an SMS with the AMI.
Right.
Do we have any status or event, let's say, SMS has started to be sent, it has successfully been sent? Can we see the queue? Can you tell us more about all this?
So right now, so there's no way to kind of really poll count how many SMS you have in queue. That's a feature we can add maybe. We definitely have an event to get a notification when the SMS was successfully sent, so you can tell that. So that you can see, and if your queue is full, we will send another error code that says the queue is full.
Can you use the SMS service while there's a voice call active?
Yes, you can. We didn't do timers, but it looked like the SMS was taking longer while there's a voice call active. But you can kind of send both simultaneously, kind of independently.
If you've got a mobile application or application where you don't have landline internet connectivity, what about possibly doing GPRS or other kinds of data over it? Is there any capability for anything other than SMS data?
For now, no. So right now, we didn't have this kind of feature. But this library can be built upon. I'm like, if eventually, because right now, exactly, most of the cards right now are pure GSM modules. Eventually, we can expand that to 3G modules or maybe even LTE, I don't know. And if that's expanded, if the hardware supports it, we can build on the library to have data communications as well.
That makes sense. And I guess theoretically, you could do any circuit switched mode that GSM supports.
Exactly.
Which would include circuit switch fax, and if you could bear the speed, circuit switch data at a blazing 9.6. But you could, I mean, I guess
Yeah.
if you're desperate, you could do that.
Yes. These are the exact same modules that goes into your cell phone. So whatever a cell phone can do, like these things can do. It's virtually having a cell phone inside your server. Well, multiple of them.
So have you heard of Chan Dongle? We were just at, that was earlier today. And have you thought about talking with those guys? Because they do pretty much the same thing just with a Huawei USB dongle. They support a GSM and I think voice calls, not 100% of the voice calls though.
Oh, no, I haven't, but yeah, I'll take a look at, what
It'd just be interesting to see these two projects come together because it's almost the same thing.
oh, that'd be nice, yeah. Like, right. Yeah, I'll kind of try. So it's, do you know who by any chance was? Okay, yeah, we can kind of, I'll try to get in touch with him by random. Prior.
Yeah, he presented here in Astrocom, so he'll be on the website.
Okay, sounds good. I'll take a look. Yeah. Thanks, I'll look for him, yes.
What's the cost for the Sangoma card?
To be honest, I don't know. Like I'm an engineer side. I don't. It's not free. I can. Yes,
you
exactly.
bring one
I
giveaway?
never had to pay for them. Yeah, I
Did you-
can't really give you a price. Sorry. Like you can we have sales guy like at the exhibit. Like they'll give you a ballpark price right away. Yeah, I have no idea.
Did you bring one to give away?
I can check with the people at the booth. There's one definitely on display, a demo one. I don't know if there was one that's being given away. Yes, yeah, we can go check with them.
The highest density is 4 GSM modules.
Yes, on one PCI slot, but you can have like.
Have you encountered any collisions by antennas that close to each other?
With 4 we've tested, we didn't get it. We know that as you add more, they're supposed to have issues with interference and shadowing between the antennas, and that's usually when people start using a combiner. So kind of have all 4 modules use a single antenna. We do have on our PCI card, there's already like some real estate left to add a combiner in the future. But right now, we didn't have people having that problem. So right now, we didn't spend more time on this. But there is supposedly, as you add more modules beside each other, like you're supposed to have a bit of interference. The other solution is some of the antennas are not just like that small stick. Some of them have a kind of a long cable, so you kind of move them away from your server and spread them out.